This is Shahul Amid, Professor ECE, Sedu Institute of Technology. This session we are going to discuss about Bode plot under linear control engineering, and we are discussing a problem. First I will read the problem statement. For the function g of s is equal to 5 into 1 plus 2s divided by 1 plus 4s into 1 plus 0.25s, draw Bode plot. This is the problem statement. So we have to draw Bode plot. In that we have to separately calculate magnitude for different set of frequencies and phase for different set of frequency. For that we have to follow some certain steps, rules and regulations in order to plot it. So starting with substituting s is equal to j omega and the transfer function, we get g of j omega is equal to 5 into 1 plus j 2 omega divided by 1 plus j 4 omega into 1 plus j 0.25 omega. So for magnitude plot, we have to select corner frequency. When you are seeing this transfer function, we have three terms. Okay, this is one term, another term is here, and third term is here. So one term is in numerator and another two terms are in denominator. Okay, now we have to find the corner frequency. Corner frequencies are determined by finding the coefficient and taking the inverse or reciprocal. So and also we have to find corner frequencies in increasing order. So by seeing this, this coefficient, that is 4 is low frequency, next one is 2 is another frequency, and the final one is 0.25. So I am taking the coefficient of j omega 4 is first corner frequency. So first corner frequency omega c1 is equal to 1 by 4, which is equal to 0.25 radians per second. Second corner frequency, the term which in numerator, that is omega c2 is equal to 1 by 2, is equal to 0.5 radians per second. The third term is in denominator, that is 1 plus j 0.25 omega, which is equal to omega c3 1 by 0.25, which is equal to 4 radians per second. So these are the three corner frequencies we are going to consider for this plot. Next we have to find slope for each and every term. When we are seeing the transfer function, we have four terms. One is 5, another one is 1 plus 2s, third one is 1 plus 4s, fifth one is 1 plus 0.25s, four terms. So we have to find the slope for each and every term, as well as we have to find the change in slope. So here starting with the constant for constant, the slope is 0, and the term which is in numerator, which has slope plus 20, and the term which are in denominator has minus 20 slope. So so this table will give you the slope as well as change in slope. So first we have to write the terms in which is in corner frequency increasing order, and so this is the first term is 5, second term is 1 by 1 plus j omega, third term is 1 by 1 plus j 2 omega, the fourth term is 1 by 1 plus j 0.25 omega. So corner frequencies are already listed in increasing order, 0.25, 0.5, 4, and the slope related to each and every term. So already told you that we have four term, two terms are in numerator, that is 5 and 1 plus j 2 omega, these two are in numerator, and these two, that is 1 plus j 4 omega and 1 plus j 0.25 omega, these two terms are in denominator. Okay, so constant term, for constant term the slope is 0, and the second term is 1 by 1 plus j omega. This term is in denominator, So the slope is minus 20. The third term is 1 plus j2 omega. This is in numerator. So the slope is 20. And the next term is in denominator, so minus 20. Now we have to record the change in slope. Change in slope, when we are seeing the slope for each and every term, so we have to find the change in slope by simply adding the subsequent one. So here the first term slope is 0, the second term slope is minus 20. We have to add these two slope and finding the new slope minus 20. So when you are adding 0 and minus 20, we get minus 20. Then next term is, again, this is the new slope. So we have to take this one and we have to add the second term, that is minus 20 plus 20, which is equal to 0. This is the new slope. So now we have to add this one and this one. So 0 minus 20 is equal to minus 20. So in this table we have got the slope for each and every term as well as the change in slope for each and every term. That is, for example, if you are taking minus 20, this is nothing but slope from omega c2 to omega c1 to omega c2, and 0 is the slope from omega c2 to omega c3, and minus 20, this minus 20 is the slope from omega c2 to c3 to omega h. Next one is, we have to find the gain for these set of frequency. In addition to that, we have to take low and high frequency, and low and high frequency must satisfy the condition that low frequency must be less than the first corner frequency, that is omega c1, and high frequency should be greater than the last corner frequency, that is omega c3. So for this case, we have taken low frequency as 0.1 radian and high frequency we have chosen 10 radians per second. So now we have to find the gain at these 5 set of frequencies, that is omega L, omega c1, omega c2, omega c3 and omega h. Starting with low frequency, that is omega is equal to omega L, that is 0.1 radian. The gain A is equal to magnitude of g omega, which is equal to 20 log that constant. In the transfer function, we have a constant 5. That constant we have to take and find the value of this term using calculator. We get plus 14 dB. Now we have to find the gain at the first corner frequency, that is omega c1, that is 0.25 radians per second. For that also we are going to use the same formula, that is A is equal to 20 log 5, the same thing, plus 14 dB. When we come to the second corner frequency, that is omega c2, that is 0.5 radians per second, we have to include the change in slope from omega c1 to c2. That is the gain A is equal to slope from omega c1 to c2 into log omega c2 to c1 plus gain at omega is equal to omega c1. Gain at omega is equal to omega c1 is 14 dB, and this term slope from omega c1 to c2 is minus 20 dB into log omega c2 is 0.5 and omega c1 is 0.25. Now we have to use calculator and find the value of log, and when you are substituting and we get the slope, we get the gain A is equal to plus 8 dB. Now we have to find the slope at omega is equal to omega c3, that is 4 radians per second. Here also there is change in slope we have to consider. So A is equal to slope from omega c2 to omega c3 into log omega c3 by omega c2. This value is 0 and this one is log 4 by 0.5 plus gain at omega is equal to omega c2. This is 8 dB. So this one we have to include 8 dB. We get the result is 8 dB. We have to use calculator to find the value of the gain. Finally, we have to find gain at omega is equal to omega h, that is 10 radians per second. Here A is equal to slope from omega c3 to omega h into log omega h by omega c3. So slope from omega c3 to omega h is minus 20 into log 10 by 4. 10 is omega h, high frequency, 10 radians per second, and omega c3 is 4 radians per second, plus gain at omega is equal to omega c3. Gain at omega is equal to omega c3 is 8 dB. So we have to use the calculator and find the value. This is 0 dB. So we got gain for different set of frequencies, that is omega low frequency, C1, C2, C3, and also omega h. So this table will give you a brief about the gain we obtained for different set of frequencies we consider. So this is omega L, this is omega C1, and this one is omega C2, and this is omega C3, and this one is omega h. Now we have to draw phase plot. For that we have to find the phase angle for the given transfer function. This is a transfer function. When you are seeing this transfer function, we have 3 complex terms. One is in numerator, another 2 are in denominator. So for numerator, the phase angle is positive, and the denominator, the phase angle is negative. So first we take the first term 1 plus j2 omega. For the first term, the phase angle is tan inverse of 2 omega and the other two terms are in denominator, so the phase angle is minus tan inverse of 4 omega. That is 4 omega is nothing but the tan inverse of imaginary part by real part. Imaginary part is 4 omega and real part is 1. So minus tan inverse of 4 omega, and the third term is 1 plus j 0.25 omega. For this, minus tan inverse of 0.25 omega. So this is the phase angle. We have to find phase angle for different set of frequency. This we can use calculator and find the value of phase angle for different set of frequencies, and we are going to include the frequency which we have already assumed, that is omega L, omega C1, C2, C3, and omega H. So these are the list of frequencies and the corresponding phase angle determined for determined using the formula pi is equal to tan inverse of 2 omega minus tan inverse of 4 omega minus tan inverse of 0.25 omega. So for 0.1 we get minus 12 degree, 0.25 22 degree, 0.5 26 degree, 2 33 degree, 4 49 degree, 10 17 degree, 50 86 degree. Now we have to plot magnitude as well as phase, and this is magnitude and this is phase. So this is similar graph. We have to consider magnitude in left hand side and degree in phase in right hand side. So we have to find the range of dB. So when you are seeing this, the range of gain is 0 to 14 dB. So it's up to the student wish. You can take anything. So here we have taken one division is 5 dB. So one division is 5 dB, and for degree we have taken one division is 10 degree, something like that we have taken. When you are selecting this, starting with 30 dB, this is 25, 20, 15, 10, then 5, 0, minus 5, minus 10, minus 15, and minus 20. Starting with magnitude plot, and in fact before plotting we have to identify the frequency. Here frequency ranging from 1 to 0.1 to 10 radians per second. So I am starting the starting with 0.1 radian per second left corner, and we know that in similar graph each and every section will be multiplied by 10. So 0.1 by 10 is 1, then 1 into 10 is 10, and 10 into 10 is 100,000, something like that will go. So starting with 0.1, here first reading is 0.1 14 dB. So here 0.1 is here and the 14 dB is here, below 15 dB, 14 dB. So 14 dB first point is okay. Second point is 0.25. 0.25 is 0.1. It's somewhere here 1. This is 0.2, 0.3, 0.4, and this is 0.5. This one is 0.5. So 0.5, for 0.5 it is 8 dB. 0.5 is 8 dB. 8 dB is below 10 dB. It is here. But in between 0.1 and 0.5 we have 0.25. 0.25 is definitely, this is 0.1, this is 0.2, and it should be in between this 0.2 and 0.3. So here somewhere here, and the gain value is 14 dB. So here this is the 14 dB one. Okay, fine. Then the third one, the fourth one is 4 radians per second. 4 radians per second. This is 1, and this is 2, this is 3, this is 4. And when you are tracing one, this point for 4 8 dB. 8 dB is above 5 and below 10. It's somewhere near here. This is 8 dB. Then finally 10 radians per second, 0 dB. So 10 radian is here. When you are tracing it, the 0 dB line. So this point. Now we have to connect all these points using scale. So and then we have to extend it. This is magnitude plot. And phase plot, when you are seeing phase plot, for different set of frequencies we have a degree. So here the phase angle degrees range from 12 degree to minus 86, minus 12 degree to minus 86 degree. So we have assumed that y-axis right hand side, each and every unit is 10 degree. Starting with 0.1 radians per second, the phase angle is minus 12. Minus 12 is below minus 10. So it's somewhere here, this one, this line. So this is the first point. Second point is 0.25 minus 22 degree. 0.25 is in between 0.2 and 0. This is 0.2 and this is 0.3. So it is in between this line. And the phase angle is 22 degree. 22 degree. It's this one. So this is second one. So below 20, minus 20, minus 22 degree. The third point is 0.5 and is minus 26 degree. Minus 26 degree below 22 minus 22. It's around here, somewhere here, and the frequency is 0.5, and this point. Then 2 radians, it's around 33 degree. 30 degree is below minus 30 degree. So it's somewhere here. This is 2 degree. Then 4 is here, and the phase angle is 49. 49 is below minus 40. This is minus 40, and is somewhere here near this one. So this one, and 10 radians per second. 10 radian, for 10 radian the phase angle is minus 70. Minus 70 is somewhere here, and it is 10. This point, and then 50 radians. 50 radians is here, and the phase angle is minus 86. So the problem they are they ask us to find magnitude and phase plot, and we have determined magnitude for different set of frequency and phase angle for different set of frequency, and we have plotted the same in similar graph. Thank you very much. Thank you.